Alrighty, let's take a crack at this problem. It's a second order ODE. It's got a non-driving term, and this will actually lead to a resonance case. So we've learned how to do some undetermined coefficients. We firstly solve the associated homogeneous problem. Okay, to do this, we let YH equal e to the lambda t, and we're solving for the eigenvalues lambda. So we sub this in there, and we obtain the characteristic equation, or the auxiliary equation. Lambda is obviously plus or minus 3i. Now we can write down our general solution to the homogeneous problem. Because we have complex conjugate roots, it turns out to be in terms of sine and cosine. We notice that our right-hand side driving term looks like one of the terms in our homogeneous problem, and therefore we have a resonance case, right? We've got a matching between the driving sine 3t term and the homogeneous solution 3t, sine 3t. All right, so we've got to figure out how to deal with this. In the case of resonance, we still make our usual hypothesis that y is equal to y homogeneous plus the particular part. We guess now, though, because we've got a resonance case, t times something that looks like the right-hand side. So if you've got a sine term on your driving in your right-hand side, you need the cosine term in your guess as well, to try and balance everything out. We take this, we'll plug it in there. So I'll just reproduce the equation. That's the easiest thing to do. Right. So we plug in our hypothesis YH plus YP. Oops, 2 sine 3t. And we note that this and this, that's identically the homogeneous problem. So they together they contribute nothing. So we're left with yp double prime plus 9yp prime, nothing, no primes, 2 sine 3t, like so. Now, once we're here, we've got to differentiate our yp. We're going to have to use the product rule to do this derivative, because we've got a product between t and all of that. So let's go. Yp prime, differentiate the first bit, leave the second bit alone. Differentiate the second bit, leave the first bit alone. Okay, now we've got to do the second derivative. Like so. Now again, we've got a product rule to do, so we differentiate the first one, leave the second one alone. And we know that that's actually exactly equal to this term in the brackets here, so we're going to get 2 of them in the end. Now I'm going to just continue writing down here. I leave that one alone, differentiate the second one. Okay. And now I've got everything I need, namely this and this goes in this equation up here, which gives, and I'll simplify this, I'll take the 2 of them. There's a factor of 3 that comes out as well. Plus the YP term. So it's 9 times the YP term here. And we can see that it cancels with the leading term that we've got in the top line. All right, so boom, go on, we're dealing with this thing. So we've got that's our sine term. We've got no cosine term on the right-hand side. So this one's got to balance with this. C1's got to be 0. C0 equals minus 1/3. And y particular is then equal to minus 1/3 t cosine 3t. Right, so be very careful that when you're subbing everything back in, you sub it back in into the correct spot. So the C0 is associated with the cosine, and there's a t. So we can write down our overall solution. We got our homogeneous part. And we got our particular part. We don't have any initial conditions. So that's the best we can do, the general solution.